This is the first unit of the first lesson of the first unit of Math 31, where we cover pre-calculus and we look at the three main topics that make up pre-calculus. The first is coordinate geometry, and so we do a review of linear relations. Stuff that you've seen before, I hope, but you need to be good at a lot of these basic topics in 31. Really, you'll find that that's the biggest challenge in the course. It's a lot of material that you've covered before, but then you move on to other things. Here you really have to get good, get really solid at basic algebra and graphing concepts. So to start off, we take a look at linear relations. And if we were to take a look at this graph like this, just a regular grid with 2 points indicated, the question is, find the distance between -3, 2 and 2, -1. Now, of course, you could simply draw this with Pythagoras' theorem, or draw a triangle, and then use Pythagoras' theorem to solve. But there is also a formula for it. And I'm going to take you to that first and then go back. The distance formula itself looks like this. And on the formula sheet that you'll be given, at least for the first half of the course, it is provided for you. So d is equal to x2 minus x1 squared plus y2 minus y1 squared. You've seen it before. And take us back to this question then. It doesn't matter, and I know you know this, but it doesn't matter which one you call x1, y1, and then x2, y2, and you just are consistent. So if you get the distance between the two, formula looks like this. x2 minus x1 squared plus y2 minus y1 all squared. D is equal to the square root of x2 is 2 minus -3. 2 minus -3 is 2 plus 3. The two negatives cancel. Squared. And then y2 minus y1 is -1 minus 2 squared. So the distance becomes square root of 2 plus 3 is 5 squared, 25, and then -3 squared. Now remember, you can pause me and stop or rewind at any point. So if you feel that the lesson is going on a little too quickly, just stop it. I do try to give you time to get things down with it, but I am working under the assumption that you do have the printed copy of the notes in front of you, just so that you can make your way through it faster. Anyways, this is 25 plus 9, so the distance, if I did the math right, is the square root of 34, which does not simplify, and this is an exact value. If you did decimalize it, you'd get 5 point something, but I think that you want to be careful with that. The questions typically are exact values, and I tell you which decimal to round to. Textbook isn't perfect with that, but I'll be careful with it on exams. So I'm just going to write this as an approximation to the nearest tenth. So be careful with that. And that is the distance formula. Works for any pair of points along the way. Now I'm going to go up ahead to where we left off and take a look at the midpoint formula. Midpoint formula is the simplest thing in math. x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if we were asked to find the midpoint as an exact value of this line segment PQ that has endpoints given, all we would do, return to that formula. So the midpoint PQ would be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Sub in everything. Again, doesn't matter which one you call x1. I'll call that square root 8 plus square root 50 divided by 2. And then y1 plus y2 is negative root 48 plus root 108, all divided by 2. Now, in order to add these together, we can't just simply put them through our calculator. We need to reduce those radicals. And I know that you've done that before, but just to remind everybody, you can only add like radicals together. So you have to have the same radicand in order to add them. And root 8, we break it down into square root 4 times the square root of 2. So the perfect square being 4, and that's always what you look for with these radicals. So it becomes 2 square root 2. Same thing with root 50. I won't always go through these ones, but I will now just to remind everybody. So root 50, we break that into square root 25 times root 2. So it's 5 root 2 divided by 2. And now because they're both square root 2's, we can add them together. I'll do that in the next step. And the negative root 48, we break this one down. The biggest perfect square that's a factor of 48 is 16. So that's 16 times 3. And then we could take out the root 16 and write that as negative 4 square root 3. And then the square root of 108, a little more difficult. You have to figure out what multiplies into that. And this is going to be square root 36 times 3. So 6 root 3. Divided by 2. Add them together now, we get 7 over 2 root 2. So that's 7 square root 2 over 2, and I'm keeping it in that form as an exact value. And then negative 4 plus 6 is 2 root 3 over 2. And then that will simplify by dividing out the factor of 2, giving you square root 3 for your y coordinate, and then 7 over 2 root 2. So that's an exact value. So you would have to decimalize it if you wanted to locate where it was on a grid. But I'm just following the instructions that were laid out in the question. So really that problem is more about getting exact values than it is anything else. Now the slope formula in general is slope is equal to the change in y over the change in x, which is usually referred to as rise over run. And if you're given 2 points, we would write that as y2 minus y1 over x2 minus x1. So you get the difference of the y coordinates divided by the difference of the x coordinates, and then you've got it. It is really a very important concept in Math 31. We'll spend a lot of time working with it, not in this context so much, but in more sophisticated ways down the road. Don't forget that the slope of a horizontal line is 0, and that the slope of a vertical line is undefined. That matters quite a bit as well. So let's work with this one. Find the slope of the line segment shown below. So far I just got the 2 points, and I didn't draw in a line for some reason. But that's okay. There is a line there, and we could very easily draw that in. Actually, a little hard for me right now. I didn't bring my ruler in, but that's going to have to do. And if we want to use the formula for this one, we just work it out. So this point is x is negative 1, y is 3. This point is x is 2, and y is negative 2, or at least it's supposed to be. So we can call this x1, y1 for the top one, and then x2, y2. Now be really careful. So you're basically just subtracting the y coordinates first, but watch your signs. So this is negative 2 minus 3. If I subtract to get the difference of the y's, and then it's 2 minus negative 1. Now I write that as 2 minus negative 1 is 2 plus 1, so I don't mess up the negative. And then this gives me negative 5 over 3. Because it's a negative slope, it means that the graph is, the line is going down. And then we have it. And I'm going to look at a few other examples. I'm not probably going to go through all of these ones, but a few examples at least. Are these points collinear? Now, if they're collinear, it means that they lie on the same line. And the one way to do that is to, well, of course, you can sort of eyeball your way through. Let me just take that back. But, you know, if you did plot these ones, 3, negative 1, we're probably going to get our answer right away. Now, in fact, this scale isn't perfect for this, but 3, negative 1 is about right there. 5, 4 is about right there. And 1, negative 6 is about there. Now, it appears that they are on the same line. But what you can do to verify is you compare the slopes. And I go AQR just to keep things a little more interesting. If we take the slope of AQ, and then we take the slope of QR, because they both include the same point Q, if we have the same slope, then it means that they have to be on the same line. So really we're just comparing the slopes. So the slope of AQ excuse the writing, is equal to y2 minus y1. So I'm going to, here's my slope formula. M is equal to y2 minus y1 over x2 minus x1. So subtract the two y coordinates and you get 4 minus negative 1, which is 4 plus 1. Watch your negatives carefully. Minus negative becomes plus. And then 5 minus 3 on the bottom. So MAQ is equal to 5 over 2. And now we do the same thing with QR. y2 minus y1 is negative 6 minus 4, all over top of subtracting the two x coordinates, 1 minus 5. So MQR is equal to negative 10 over negative 4. And when we simplify that fraction, we get MQR is equal to 5 over 2 by dividing by negative 2. So MAQ is equal to MQR. So therefore, that's the symbol for therefore, AQR are collinear. Guess I should say the points AQR. Now, in this first batch of questions you get lots of stuff like that where they're really just asking you to do all these comparisons and get good at the formulas you have in front of you. Now, this next question is saying, if these are vertices of a triangle, is ABC a right triangle? Now, this leads us to an important point. And the important point is this. Well, fairly important point, is that parallel lines the slopes are going to be equal. Let's write that like this. Slopes are equal. So for example, if line 1 is parallel to line 2, then M1 is equal to M2. So the slopes will be equal. That makes sense to people. But with respect to perpendicular lines, if line 1 is perpendicular to line 2, then M1 times M2 is equal to negative 1. And that simply means slopes are negative reciprocals. Of each other. So you flip them over and you change the sign. And that would mean that the product is negative 1. So if we were to do this question, in order to identify whether this is a right triangle, we want to compare the slopes. So here's a diagram. Now again, you can pretty much tell by inspection. 3, 0. So it kind of takes the fun out of it. Negative 4, 4 is right there. And then negative 1, negative 2 is right there. So what I would suggest that we do by inspection, we just compare the slopes at this point right there, which is point C. So you take the slope of AC, take the slope of BC, and then you see what happens. So MAC is equal to, subtract the y coordinates, negative 2 minus 0. So I subtract the two y's, y2 minus y1. So m is equal to y2 minus y1 over x2 minus x1. And then you have that over the two x coordinates, which is negative 1 minus 3. So MAC is equal to negative 2 minus 0 is negative 2. Negative 1 minus 3 is negative 4. So the slope of AC is equal to 1/2. And then we do the same thing for BC. Because we've got this graph in front of us, a little bit of the mystery is missing. But here we subtract the y's. So 4 minus 0, and then negative 4 minus 3. Oops, let's do this right. It's BC, excuse me, we were just about going to have a catastrophe there. BC. So BC is equal to, how about negative 2 minus 4? Order doesn't matter as long as you're consistent. Negative 2 minus 4. And then negative 1 minus negative 4 is negative 1 plus 4. So MBC is equal to negative 6 over 3. And then we get MBC is equal to negative 2. So now we can use notation. We can say that since, now the symbol for since, in case you haven't seen it, is the upside down of therefore. So since the product of MAC and BC is equal to negative 1. And that's true, right? Because 1/2 times negative 2 over 1, well, they're negative reciprocals of each other, so that means you're going to be left with just negative 1. We can now say, therefore, BC is perpendicular to AC, so therefore, triangle ABC is a right triangle. Type of thing you can do. So there's lots of practice on these ones. It's not critical information, but the idea is to get good with linear graphs. Now you'll notice that your lesson notes go on a bit, but I will pick that up on the next one. I'll break this into 2 lessons just to keep them a little bit shorter. So thank you for your time.